Okay, so here are some worked solutions for page 20 in your packet and also some textbook problems. This is Mrs. Page. As you can tell, I'm not feeling too well, but I wanted to make sure you guys got a good review before your test, so just bear with me. I don't have much of a voice left. You should already have this page in your notes. So we're going to go ahead and skip that. Here we go. This is number 5 on page 19. It asks if your car will have enough time to stop, given the parameters of an initial velocity of 13.4, a distance of 20 meters, and a deceleration of 6. Okay. Now here, let me move this over so you can see it. You have to ask yourself two things. All of you have been in a car, and you know that as you're approaching a stoplight, sometimes the light does turn red before you stop. You can see it in the distance. It doesn't mean that you've gone through the intersection. So you need to know, one, if you have enough time to stop, but two, also if you have enough distance to stop, given the speed that you're going. So the first thing I did is I wrote down my givens, which are right here. And then I decided, since I was missing time, I was going to go ahead and solve for time. And I did that. And you can see that I'm still learning how to use this program, sorry. You can see that it was 2.23 seconds, which is longer than the amount of time that the light was going to turn red. But that's okay, because now we have to check and see if we have enough distance. So I went ahead and I solved for x using the big long distance equation, my initial velocity, the time I had solved for, and you can see that you've got 14.8 meters to stop. The next slide is number 8. Let me see here. No, wrong. There we go, right. Sorry, this is all still new. Here we go. It's number 8 and number 9, so I'll kind of zoom those out so that you can see them both. 8 is the cat who falls down. I believe we did that one in class already. And 9 is King Kong falling off of the Empire State Building. I believe that we did that one already too. So for this one, you are just solving for distance using the big giant equation. We have y now instead of x because we're falling instead of moving horizontally, so that's why we wrote it as y. And you also want to remember that gravity is negative 9.8, so when you're solving for how fast King Kong falls to the ground, technically that velocity is negative. So you can, of course, pause this video at any time to take a look at those. Here we go to number 11. Whoops, hold on. Okay, for this one, something is thrown up into the air, and then it also comes back down. And the trick is to be really careful with the time component when you have something thrown into the air and then coming back down. You want to remember that when something goes up, when it gets to the very top of its path, its velocity is 0. But what is its acceleration? If you said 0, you're not right. Its acceleration will always be gravity. Gravity is what's causing it to slow down and to speed up. So its acceleration is still going to be negative 9.8 meters per second squared. So that's an interesting case when you have something that goes up into the air and it gets all the way to the tip top. Its velocity is 0, but its acceleration is negative 9.8. So you want to be careful with that. especially on the conceptual part of the test. That will very likely be a question. So it asks how long the ball is in the air. Well, you can look at it two ways. You can look at it from where it started to where its speed runs out at 0. So you can think about it from going from here up to where the speed runs out. Or you can think about something that's just dropped, because at the top its velocity is 0, and then it falls back down to the ground here. So you are just calculating for time for 1/2 of the trip. So you got to be careful there and make sure that you realize that the 3 seconds that you get when you take velocity divided by gravity is just the time to the top. To get the total time here, you have to take that number and multiply it by 2, because it went up and then it came back down. Part B asks how high off the ground did it get? Well, that's no different than number 9 and number 11, where you're looking at the cat and at King Kong. You can picture the ball just going from the top of its path to the bottom, or the other way around, from the bottom of the path to the top. It's the same distance. So you're just going to plug in the time to the top, not the whole time, so be careful there, to get your height. And then C is asking how fast it was going when it comes back down. And anytime you throw something, it's going to come back down at the same speed that you threw it at. So you can take a look at that. Okay, for number 14, this one is a little bit tougher. What you're going to want is to, I'm going to zoom out a little so you can't see that number 15 just quite yet. It's talking about people going TPing. They're throwing some toilet paper up in the air. And instead of asking how high off the ground it gets or how long it takes it to get there, the question asks how fast is it going when it reaches 15 meters off the ground. So what you need to do is, using your height equation or your distance equation in the y-axis, you need to plug in 15 for your y, and you end up trying to solve for t here. And what you're going to end up with is this very nice formula here that you will need to use your quadratic formula for. Now, many of you have this in your calculator already, and if you don't, ask your math teacher. They can load that for you today. In fact, Miss Trent said you could come see her during seminar today, and she will load the quadratic formula program for you. It is amazing. You just plug in your A, B, and C, and it gives you your answers for you. Those of you that do have it, that forgot where it might be, on your calculator, if you want to take that out, it's under Program. And then you click, I think, ACT, and then Algebra, and then Quadratic. And it's in there. Ask your neighbors for help. You'll see it's in there. Go see Miss Trent. She's in C200, and she will load that for you. So once you get this equation set up, and if you've got that program in your calculator, it's just, real easy. You plug it in, you get your time. The reason there are 2 times is because what goes up must come back down. When it gets to here, it takes 0.99 seconds, but then it continues to go, and it comes all the way back down to here, which took a total of 3.09 seconds. Now, 15 is below here. So I'll let you take a look at that. This is not a very good picture of a pole vaulter. But again, you can see we're solving for time. We want to know how long they were in the air. We know the height of the pole vault, 6.1 meters, is pretty straightforward. I ask how fast it's going, in which case you just need to know how long it was in the air. And then the last question asks for the average velocity, which you can take by just taking your initial plus your final and dividing by 2. Now we're on to the textbook problems. If you want to go ahead and get out your textbook, you can see that number 42 in your textbook here is very much like the toilet paper problem that you just solved prior to this. So I will let you just take a look at this, and remember that you can use your quadratic formula program to solve for that. It's the same thing. You've been given y, and they're asking you to find time. So you got to set up that equation and solve the quadratic. Also, it asks you how fast it's going at 11 meters. So I went ahead and took the time on the way up and plugged that in for the velocity there. So you can take a second and look through that one. Number 44 is a pretty tough problem. It asks if there is a rock falling. So I've got a rock here, and it's falling down, but it started up above. It says if it passes by your window and it takes 0.28 seconds to pass by, and your window is 2.2 meters tall, how high up did it start from? So that's a pretty complex problem here. Let me back this out so that you can see the solution. I'll let you take a look at that yourself, but typically what you want to do is start at kind of the top of the window here and figure out how fast it was going when it got there. So what I did is I decided to find the initial velocity at the top of the window. I'm using my distance equation because I know my height, so I plugged in the 2.2 for the height. I plugged in the amount of time that it took, and I went ahead and solved for my initial velocity. And once you know your initial velocity, you can figure out how much prior to that was it at 0. And so you can see down here I just used my velocity and gravity to find time, and then I used time to find my height. So again, you can check that one out on your own. That's a pretty tough one. If you can work your way through this one, you're doing great. Okay, that's all for this video. Don't forget you can rewind and pause. Thanks.